It's the dead of Antarctic winter, 24 hours of darkness, temperatures cold enough to snap steel like a twig, and in the middle of an unbroken shield of sea ice, hundreds of miles from any coastline, a hole tears open. Not a small one, a hole the size of New Zealand. Warm ocean water sitting exposed right next to the coldest air on the planet. It shouldn't be able to survive an hour out here, but it sat there for weeks. Then it happened again the next year, and then for 40 years it vanished completely, as if it had never existed at all. Scientists had no idea why it was there, and no idea why it left. In 1974, one of the first weather satellites ever put into polar orbit sent back images of Antarctica's Weddell Sea. And buried inside the sea ice, researchers noticed something that made no sense: a dark patch of open water sitting in the middle of the ice pack, far from the coast. At first, they assumed it was a sensor glitch. Satellites in 1974 were new technology, and errors were common. But the images kept coming back the same way, winter after winter, for 3 years straight: 1974, 1975, 1976. A massive opening, roughly the size of New Zealand, sitting in the middle of some of the most hostile ocean on Earth. Scientists gave it a name, the Weddell Polynya, from the Russian word for hole in the ice. And then, just as suddenly as it appeared, it stopped. No one saw it again. Not in 1977, not for the rest of the decade, not for the rest of the century. For 40 years, the Weddell Polynya became a kind of ghost story in oceanography, a real, photographed, undeniable phenomenon that nobody could explain and nobody could find again.
To understand why this is so strange, you need to understand what a normal polynya looks like, because most of them make perfect sense. Near the Antarctic coastline, strong katabatic winds, dense, freezing air that rolls down off the ice sheet, regularly push sea ice away from the shore, opening up strips of water. These coastal polynyas are common, predictable, and well understood. They form basically every winter in the same places for the same reason: wind physically shoving ice out of the way. The Weddell Polynya is not that. It doesn't form near the coast. It forms far out in the open ocean, in one of the most remote, storm-battered stretches of water on the planet, hundreds of miles from any wind-driven coastal effect. Open ocean polynyas like this are rare, almost to the point of being freakish. Before satellites, nobody even knew they existed. So the question wasn't, why does ice sometimes move? The question was, what could possibly punch a hole the size of a small country in the middle of the sea, in the middle of winter, with nothing nearby to cause it?
Here's what makes the hole genuinely bizarre. Antarctic winter air above the Weddell Sea can drop below -40 degrees Fahrenheit. Ocean water, even at its saltiest and densest, sits just below the freezing point, around -1.9 degrees Celsius. Put those two temperatures next to each other with nothing insulating them, and you get an enormous exchange of heat, pouring out of the ocean and into the atmosphere. Under normal conditions, that heat loss should do exactly one thing: freeze the exposed water almost immediately and reseal the hole within hours or days. Instead, the Weddell Polynya sat open for weeks, sometimes months. That means something was actively working against the freeze, pumping enough warmth up from below to keep pace with one of the most extreme heat losses anywhere on the planet. Whatever was driving this had to be powerful, and it had to be sustained. A one-time event wouldn't cut it. This needed a continuously operating engine, hidden somewhere beneath the ice. After 1976, researchers kept watching. Satellite coverage of Antarctica only improved over the following decades. Resolution got better. Coverage became constant, year-round, storm and no storm. And the hole never came back. By the 1990s, some scientists had started treating the original Weddell Polynya less like an ongoing phenomenon and more like a historical curiosity, a strange one-time event, possibly tied to ocean conditions from the 1970s that simply didn't exist anymore. Climate models built afterwards struggled to reproduce anything like it. Some researchers wondered if the exact conditions that created it in 1974 might never happen again in a human lifetime. That's the tricky thing about explaining something you can't observe. You're left studying photographs and guessing at causes. For a phenomenon rare enough to vanish for 4 decades, there simply wasn't the data to test any theory properly. The Weddell Polynya had become the kind of mystery that gets a paragraph in textbooks and then quietly drops out of the conversation, until the ocean decided to bring it back. In 2016, satellite images picked up something researchers hadn't seen in 40 years, a large opening in the Weddell Sea ice, right around the same underwater feature as before. It closed up again by the following spring, and scientists barely had time to react. Then in 2017, it happened again, and this time it was even bigger. At its peak, the opening stretched over 115,000 square miles. That's larger than the entire United Kingdom. For the first time in living memory, researchers had modern instruments in the water at exactly the right moment to actually watch it happen. This time, nobody was going to let the data slip away. Robotic ocean floats, autonomous drifters, and even seals wearing satellite tags were already gathering readings in the region as part of an unrelated climate monitoring program. Almost by accident, scientists had a front-row seat to a phenomenon that had escaped explanation for 2 full generations.
Piecing together what actually happened required data nobody would normally put in the same sentence. Satellite thermal imaging, robotic floats drifting a mile below the surface, and yes, wild seals swimming under the ice with sensors glued to their fur, logging temperature and salinity as they hunted. The floats had drifted directly into the region above an underwater mountain called Maud Rise, a seamount roughly the size of a small country, rising up from the ocean floor without ever breaking the surface. And they'd gotten trapped there, circling for years in what researchers realized was a slow-spinning vortex sitting directly above the peak. Meanwhile, satellite data showed a string of intense winter storms battering the region in 2016 and 2017, nearly hurricane-force winds sweeping across the open ocean, mixing the water violently from top to bottom. Individually, none of these were new discoveries. Underwater mountains were known, storms were known, but nobody had connected them to the disappearing whole because nobody had ever caught all 3 happening in the same place at the same time with the instruments in position to prove it.
Here's what actually has to happen all at once for the Weddell Polynya to form. Deep below the surface sits a layer of warmer, saltier water left over from ocean currents circulating around the globe. Normally, a lid of colder, fresher water sits on top of it, sealing it in, like a layer of oil floating on vinegar, refusing to mix. Step 1. Maud Rise, the underwater mountain, physically forces deep water to swirl upward around its slopes, creating a spinning vortex directly above the peak. Step 2. Intense winter storms hammer the surface, driving what oceanographers call Ekman transport, wind-driven currents that push surface salt sideways across the top of that vortex, like scraping icing off a cake. Step 3. Without that salty top layer to protect it, the barrier collapses. Warm, dense water from below breaks through to the surface, melting the ice from underneath and venting heat directly into the atmosphere. Individually, an underwater mountain isn't rare. Salty storms aren't rare. But all 3 lining up, the mountain, the storm-driven salt transport, and the specific ocean conditions to make the water unstable enough to flip, is vanishingly rare. That's the actual answer to the 40-year mystery. Not one single cause, but a precise stack of conditions that has to click into place simultaneously in one of the most remote patches of ocean on Earth.
The Weddell Polynya isn't just a curiosity. When it opens, it acts like a chimney, venting the deep ocean directly into the sky, releasing heat and dissolved carbon that have been locked away for decades, maybe longer, into the atmosphere over one of the most climate-sensitive regions on the planet. That deep water, once it reaches the surface and cools, becomes denser and sinks again, helping drive a slow, planet-wide current system that circulates heat between the poles and the equator. Some of the coldest, densest water on Earth is manufactured in exactly this kind of process. Understanding when and why these holes form isn't just about solving an old mystery. It's about understanding one of the valves that regulates how much of the ocean's stored heat and carbon gets released back into our atmosphere, and how that valve might behave differently as the planet keeps warming. A hole that vanished for 40 years turned out to be one of the ocean's pressure release valves. Nobody was watching until, for one winter, everything happened to line up.
If you liked the video, hit the like button and subscribe to things that make you go and we will keep you thinking.